So everyone, you can see my screen, right? So here we have already discussed some of the two algorithms. So first one is agglomerative clustering algorithm is one of the type, and next algorithm type is k-means algorithm. So let us see the theoretical part of agglomerative clustering, how it will work, all those things. So when it comes to the agglomerative, so if you see below, each and every thing is our entire data set. So for example, if I am having 1,000 rows of data, so each and every point is like one cluster. First of all, the agglomerative clustering will assume like that. So next, immediately what it will do, similar type of data points, it will group it. So some other groups, for example, 1,000 groups will be divided into next in the next phase. That means in the next iteration, it will be divided into, let us suppose 600, 700 like that. Again, in the next phase, again, it got divided into groups like this. If you see the dendrogram here, below line is completely my data set. Next clusterings. See clearly here. Each and everything will represent the cluster graph here. Same. So again, it will be divided into another clusters. So these simple clusters, again, it divided into one cluster. This remaining part is divided into another cluster. Like that, again, it divided into this cluster. So again, this cluster is able to combine with this cluster, and this cluster is able to combine with this cluster, and the same here also. Like this, in the visualization, the entire data I was able to cluster into. So here is the one final group, and here is the another group. So or else what you can do, if you want to make it 4 groups, you can make it like this. So this is one group, and this is another group, this is another group, and this is another group. Or else at the final shot, you can make it one group also, but this is not the correct way. So what is the use of making it in one cluster? So either we need to divide our data into 2 clusters, 3 clusters, 4 clusters, 5 clusters, or 6 clusters. So what we need to do? So to work with this, we need to read the data set first of all, and whatever the columns are not needed for us. So here in the example, customer ID. So customer ID is simply here is nothing but it is also in the format of 0, 1, and 2 only. So this is also not needed for us. So we will be dropping this. So here I do have some null values. Anyway, I know already how to fill those null values. So that's why I have used the methodology called ffill. So what you can do, you can try with bfill also. You can try with bfill, you can try with mean, you can try with median, you can try with mode, anything, whatever it is. Or if you want to fill with any particular value, you can fill with any particular value also. It's up to you. So like that, you can fill the null values. Next, I'm just checking the shape. So how many rows and how many columns? So here I do have 8,900 rows and I do have 17 columns. So I'm just checking the header. So next thing is the concept of standardization and normalization. We need to discuss about this standardization and normalization. Let us see the formula for standardization and the formula for normalization. For standardization, this is normalization. Let me copy this. See, what is the use of this normalization and standardization? First of all, we should understand. If you see the values here, in the balance, the values are within the range of 40, 3000, 5000, 6000 like this. And the balance frequency, if you see the numbers here, it is 0.81, 0.90. So here the range of values is very less. In this example, the range of values is very high. So like this, we have already discussed. See here. Here credit limit is 1000. Normally the credit limit always will be in thousands and lakhs only. And tenure, if you see the tenure, always it will be in the numbers only, like 1, 2, 3, 6, 9, 12, 15, 18, 21 like that. But this credit limit is always in the thousands. By using this standardization and normalization, we will be making the range of multiple columns into one specific range. One specific range. That is what we have mentioned here. See what it is mentioning. Normalization is a data processing technique used to adjust the values of features in a data to a common scale. To a common scale means, so here the credit limit is in thousand and lakhs, and the tenure in numbers like 5, 6, 12. So this feature credit limit data and this tenure data will be converted into the ranging between 0 and 1. See, that is what the meaning here. So normalization is a scaling technique in which values are shifted and rescaled so that they end up ranging between 0 and 1. Okay, the formula for this normalization is this one. What is this? Yeah, x minus x minimum divided by x max minus x minimum. So that means in this feature, for example, if I am taking credit limit, so this credit limit maximum value I will be taking on this column. So what is the maximum value? Let us write the formula. So x minus x minimum divided by x max minus x minimum. X minus x minimum divided by x max minus x minimum. If you calculate this, for each and every value will be calculated. Each and every value will be rescheduled. So for example, here in this credit limit feature, if you have minimum value, for example, minimum value equal to 100. So maximum value equal to 65,000. Then what is my present value? It is my present value. This 1000. This 1000 is my present value. That means for one data point. 1000. So if you apply all these values in the formula, so 1000 minus what is the minimum value? So 100 is the minimum value divided by what is the maximum value? 65,000 minus X minimum. So that is minimum is 100. If you calculate entire thing, 1000 minus 100 divided 900 divided by 64,900. If you do the calculation, 9,000 divided by 64,900. 900 divided by 64,900. 0.013. 0.013. 0.0138. So now this value 1000 got converted into 0.0138. See here, this 1000 converted into 0.0138. Like this, the entire values will be converted. All the feature values, all the column values, we will be converted into one specific range. That is the meaning of this normalization. So now let us see the standardization. The both techniques are same only. The working nature of and the formula which we will be using in normalization, in standardization is different. So normalization is scaling technique in which values are shifted and rescaled so that they end up ranging between 0 and 1. It is also known as min-max scaling. We need to remember this definition. If you don't remember this formula also fine, but you need to remember this definition. You need to by heart it. Same scenario with standardization. So these are all the differences between standardization and normalization. We say here. The formula for standardization is nothing but x minus mean divided by standard deviation. That is what it is mentioned. X minus mean divided by standard deviation. So here equation is x minus minimum divided by maximum minus minimum. If you see the normalization, it will rescale values to the range between 0 and 1. Standardization centers data around the mean and scales to a standard deviation of 1. If you apply standardization, the feature, for example, whatever the feature we are trying to standardize, that feature mean will be converted into 0 and the standard deviation will be converted into 1. Okay. So these are all the useful things. So the differences between normalization and standardization. So these are all the 5 points you need to remember and you need to by heart. So useful when the distribution of the data is unknown or not Gaussian. Useful when the distribution of the data is Gaussian or unknown. So if the data is Gaussian distribution, then we can use the standardization. If the data is not Gaussian, then we can use normalization. So same, it will be sensitive to outliers. So it can't handle outliers, normalization technique. But standardization technique, at least it can handle some of the outliers due to its formula of x minus mean divided by standard deviation. This is the important point we need to remember. Less sensitive to outliers and sensitive to outliers. Sensitive to outliers means it can't handle outliers. Less sensitive to outliers means it can handle outliers. So next, retains the shape of the original distribution. Changes the shape of the original distribution. For example, whatever the data distribution I do have, it will retain, it will maintain the same. But in standardization, it will change. The shape of the distribution, it will change. So now, it may not preserve the relationship between the data points. It will preserve the relationship between the data points. At least you should be in the situation to explain these 4 points. At least these 4 points are important. It's better to remember each and every point. Why? Because this is one of the major interview questions. Everyone will get it. What is the difference between normalization and standardization? If you prepare now, then you can easily explain these things. See, there is no need to apply this formula by using the Python code. There is no need. We have already libraries are there. So in those libraries, they have already developed the Python code by using these formulas. So simply, we need to import the library and we need to use it. Nothing more than that. What I have done here, see here. sklearn.preprocessing import standard scalar, comma normalize. So these are all the techniques. So if you want to import this normalization, what you can do, you can need to input another module called min-max scalar. That is what it will represent. So if you want to check the code flow, see here. Data normalization with say scalar. What we need to do? Scalar on train data, and we need to transform on the test data. So once it is done, everything will be converted into the normal range. So this is the original data set before conversion, and this is the data set which after conversion. What you need to do? You need to check the data frame before conversion and after conversion also. So this is one of the pre-processing technique. So that's why whenever we have imported from sklearn, it is mentioning sklearn.preprocessing. If you are importing clustering algorithms, you will be importing dot cluster. So agglomerative cluster like this. See here. sklearn.cluster import agglomerative cluster. Same in the place of agglomerative clustering, you can import k-means clustering also. So we'll see regarding that one also. So what I did, I imported libraries and I imported the CSV file. I applied standardization. So what you can do, you just need to take this. I will send this link to you guys. I will be uploading that link in the Jupyter notebook. What you can do, you can go through that and you can execute the code, whatever we do have in your you can execute. So the entire code, whether if you want to go ahead with normalization, see here what I did. First, I did standardization. Again, what we did normalization. So anything, if I want to go ahead with only standard scalar, I can go ahead. Again, what I did, again I did normalization. So I can do anything. So once it is converted, so this PCA I have applied. So PCA is nothing but principal component analysis. Principal component analysis. So this principal component analysis we will be using to reduce the dimensions of the data. We reduce the dimensions of the data. So dimensions is nothing but each and every column is one dimension. So here I do have 17 columns. 17 columns means 17 dimensions. So what I need to do, so these 17 dimensions, I want to convert into 2 dimensions or 3 dimensions or 4 dimensions. It's up to me. Why? Because I can't handle these many features. I don't want to use these many features. What I need to use, I just need to import the library related to PCA. Let us see the library name, whatever we have imported. See, from sklearn.decomposition. So decomposition means we are composing. So import PCA. PCA is nothing but dimensionality reduction technique. So for example, if I have 500 columns of data, if I want to convert into low dimensions like 5 or 10 or 20 columns, I can use this PCA concept. So this is principal component analysis. This is also one of the important concept. This is also one of the pre-processing concept. What I need to use, I just need to import the library, and in the library, I need to provide the parameter called number of components. Number of components means it is trying to reduce my 17 columns into the 2 columns. If I use 3, it will reduce into 3 columns. If I use 4, it will reduce into 4 columns. In the column names, I just need to provide the column names like P1, P2. If I am giving 4, I need to add another feature, P3. So if I want to get 4, I just need to use P3, comma, P4. You can give any name. There is no specific thing of providing P1, P2 only. So here P is nothing but principal components. So this is principal component analysis. So let us see the formula for principal component analysis. However, we do have formula for this standardization and normalization, right? In the same way, we do have formula for PCA also. So everywhere there is formulas will be there in the machine learning, but it's better to understand the working nature of that concept. Okay, the working nature of that concept means what is the use of that PCA, why we are using that PCA, like that we need to understand. So the formula for PCA is, so first it will calculate covariance matrix, and next it will calculate eigenvalues. So eigenvalues is nothing but this eigenvalues normally we used to do in matrices. In a matrix we will be using. So this is the process. A dimensional training, all the features we will be providing, and we will be computing the mean, and we will be computing the covariance matrix, and next the spectral decomposition, like how many vectors we need to form, like how many features we need to form, it will create. So by using this entire mathematical thing, we will be creating principal components. There is no need to go in depth of these concepts. Wherever needed in depth of concept, I will be explaining, don't worry, but you should understand what is PCA, what is the use of PCA, why we will be using PCA. Those answers you should do. So first, it is a dimensional reduction technique. That is the first answer. So what is the use? So we can't handle, if we can't handle those many features. So that's when we will be using less features. We will be using this principal component analysis, and we can do that. Okay. So what is the use of this standardization, normalization, PCA? So first what we will be doing, first you will check the model, you will train the model and you will check the accuracy. Next again, you will try standardization and you will check the accuracy. Again, you will try the normalization, you will check the accuracy. And next, you will try the PCA with multiple components like 2, 3, 4, 5, and you will check the accuracy. See, in the first example, I have given PCA with 2 features. Now I have given PCA with 5 features. Okay, so the next concept is Silhouette score. Silhouette score, we will be using this Silhouette score to tell how many clusters we need to divide our data. Why? Because I don't know, right, how many clusters I need to divide. So there should be one methodology to divide that. So that concept is Silhouette score is one of the methodology. There is another method is there called elbow method. That elbow method we will be discussing in another session. So for this session, we will be confining with this Silhouette score only. This Silhouette score, normally this ranges values between -1 to +1. So if the value is nearby +1, that means all the clusters are divided perfectly. If the Silhouette score is 0 or negative, that means all the clusters are not divided perfectly. That is the difference. Okay, so what I'm doing, I'm just using the visualization technique to see the how this dendrogram will be represented. So what I'm doing here, I'm using agglomerative clustering. What I'm trying to do, I'm trying to do it in divide it into 2 clusters. So immediately my data got divided into 2 clusters, and one red color is representing one cluster and one blue color is representing another cluster. So this is the way of using agglomerative clustering. In the same way, in the place of agglomerative clustering, what you need to use, you just need to use k-means cluster, nothing more than that, simply k-means algo model. It's just like one parameter. So what you will be using? So that code also we will be discussing another session. So k-means this meaning may not be, this framing may not be correct. Ignore it. So in the k-means clustering, so here what we will be using, number of clusters, how many we need to provide. So whether I want to go 5 or I want to go ahead with 10 or I want to go ahead with 6. So like this, I need to test it. So where it is working properly, where my data is dividing perfectly. So next phase, I'm trying with 3 clusters. See, red, blue, and green. Same. Next clusters 4, 1, 2, 3, 4. Next 5, 1, 2, 3, 5. Like this, I'm testing each and every how it is performing on its clusters, how the data is dividing into multiple clusters. So the next question is, how can I tell where my data is dividing into clusters perfectly? To tell that, we will be using this concept called Silhouette score. So this one minute, guys. Everyone audible or only Karthik having issue in my voice? I just saw the message now. Everyone clear, right? Able to hear me? Guys. Okay, okay, fine. Okay, thank you. Okay, so now cluster 7. So like this, I am testing 2 clusters, 3 clusters, 4 clusters, 5 clusters, 6 clusters, 7 clusters. So I can't check like this, step by step, again and again, again and again. So that's why there is a concept called Silhouette score. By using this Silhouette score, to calculate this Silhouette score also, there is another mathematical formula. See, this is the mathematical formula. So B minus A divided by maximum of B minus S, where it is representing mean distance between the observation and all the data points in the same clusters. So ignore this formula, just know about this Silhouette score and the range of this Silhouette score. That is enough for you guys to crack the interviews on those things. You should know the concept and you should know the working nature of those concepts. Why? Because we can't explain entire mathematical things during the interview. Maybe very rare companies like Amazon and Google, those companies, they will ask mathematical formulas. But in the regular thing, we don't need all those things. So what I'm doing, I'm creating an empty list of Silhouette score and I'm calculating whenever AC2 means I'm doing agglomerative clustering with 2 clusters. Same agglomerative clustering with 3. Agglomerative clustering with 4. Same agglomerative clustering with 5 and 6 and 7. So like this, I will be calculating Silhouette score for each and every cluster division. Whatever the Silhouette score I got it, I am doing a plotting. So K is number of clusters and the Silhouette score is the score for that clustering group. So when I was divided into 2 groups, my Silhouette score is like 0.5, let us suppose. When I divided into 3 clusters, my Silhouette score is 0.7. Whenever it is 4, Silhouette score again reducing. 5 reducing, 6 reducing. That means wherever I am getting highest Silhouette score, that is by optimal number of clusters. So wherever I am getting highest Silhouette score, I will be taking that as optimal number of clusters. So that means I need to divide my data. That is, I need to segment my data into 3 clusters. That is the mean. So that means, for example, here I do have 9,000 rows or 10,000 rows, whatever it is. So it will divide, for example, 2,500, 3,500 rows to cluster 1. So 4,000 rows to cluster 2. And next 4,000 over 3,500 over. So how many? 2,500 left. To cluster 3. Okay. So how it is divided into this entire rows of data. So for example, in our example, we do have 9,000 rows of data, 8,900. So based on each and every data point. So for example, if some of the persons having what I can say, their credit limit. So credit limit is one of the feature. So based on that credit limit, it can divide into clusters. It may not be, there is no need of dividing entire data into 3 groups. It is not, there is no need. So 3,500 are similar. So here 4,000 rows of data is similar. Here 2,500 rows of data is similar. Like that, it will do. Okay, so this is the Jupyter notebook which we have discussed about this agglomerative clustering. And next, what I am giving you guys, I am giving you this code, entire code. This is one entire project code. This is based out of the insurance company. This we have implemented in real-time domain, and this is real-time project. So here, based on this insurance information, so code generation date, offer billing method, payment frequency, product type, age of application received. So all this, by taking this data into consideration, I need to divide my data into multiple groups. And one more thing, in the clustering, there is no need to divide the data into training and testing. Entire we will be taking as an entire data for model training. So we will be passing. This will be called as model training. We will be using dot fit, right, for that issue. Yeah. So agglomerative clustering, number of clusters equal to 2, right? So whenever we are using this fit, it will be treated as model training. So here, this is simple thing. I didn't mention clearly, but in this clustering project, I have mentioned it clearly. If you see, the dataset size is 4,58,000 and the number of columns is 15. So what I am expecting from each and every one is just go through each and every line of code, just execute the code step by step and try to understand on your own and make a note of all of your questions one by one. So during our next session, we will clear all of our doubts. It's like two-way communication. Just ask, we will go one by one. So we will go line by line and we will discuss however we have gone through this agglomerative clustering. Right? In the same way, this is one project where we need to cluster insurance related customers into one group. Like we need to segment. So here I modified some of the date times. I extracted some of the month, some of the column. Just try to understand your end. If you don't understand also, no issue, but I want everyone to try. That is my expectation. Anyway, I will explain each and every code, each and every line of code. See, everything we have already discussed, except maybe some 1 line, 2 lines of code. This group by operation, we have discussed. Maybe this date time extraction, we haven't discussed. So that's why whatever we have missed in our sessions like Python classes, we will be covering all those things in our real-time project. See, Lambda we have already discussed. So here it is explaining how we have used this lambda in the real time. What you need to do, we just need to go through each and every line of code. We just try to understand how I did, what is the use of doing that. See, here I check null values. All these columns will be null values. All these things. Dropping in. I'm dropping some of the columns wherever null values are there. Just try to understand, just try to execute the code. Okay, you should take it and execute the code. Wherever you are not understood, just mark it. For example, if you didn't understand this line of code, so make a mark it. I need to discuss like that. So then only you can clear your doubts. It will be more effective. It's two-way communication. What is the use of explaining from my end only? I can explain it within half an hour. But I need two-way communication. So here in this function, just explore it, what we are trying to do. What is the line of code we have written? So this hash means we have commented on that. Just check it. Each and every line by line, code by code, check it clearly. Just see. And here I used one technology called label encoder. Just copy it and check it. Just check it in the Google. I will explain again. What is label encoder? Like that. If you explore, then only you will understand more the things. Okay, so we have seen unique methodology. So what is that unique? So next, what we are doing? We are just imported k-means algorithm. So what I'm doing, same way I already told you, number of clusters equal to 3. Random state equal to 10. If you take random state equal to 10, it will take the same data. So what I'm doing, fit, I am providing the data. So whatever the data we do have, that variable name I provided. So last session, I told you, right? The model itself will create some labels. To get that labels, what I need to use, this k-means variable, I need to fetch labels underscore. If I fetch that label underscore, it will give labelings like 0, 1, 2 to my data. So what I got it at the final thing, I will be getting this label also as my final data set. So cluster. So this is the extra column which I got. So 1, 0, all these things. So next I tried with 10 clusters. So like that. Some errors are there. Just try to fix it. I know what those errors. I only added it. Just try to fix those errors. And next I told you, right? Apart from Silhouette score, there is another method to tell optimal number of clusters. So this is within cluster sum of square. Don't worry, next session we will discuss this concept within cluster sum of square. Like Silhouette score, this is another method to check optimal number of clusters. So from the above graph, we can say that the optimal number of clusters are 5. So we are fitting the model with 5 clusters. So here also I have mentioned Silhouette score, all those things. So what I'm expecting from each and every one of you. So please go through these two codes clearly, step by step, one by one, line by line. See, when I divide it into multiple clusters, this is one cluster, this is one cluster, this is another cluster, this is another cluster, this is another cluster. Like this, I was able to divide. Just go through the code, try to understand, try to Google it. You will get explanation clearly. If you don't understand, if you want to understand then and there, just ping in the WhatsApp group. I will give any blog referral for you to read. You can read the blog and you can understand. If you understand, you can just say like, okay, I understood, like that. So my intention is like clearly, you should have a habit of reading the blogs. However, I have checked this standardization, normalization formula. In the same way, you need to check here also. Clear, everyone? Already, whatever the code I have explained, it is already there in the folder. It is there in the folder name is in our October ML batch folder. Machine learning code folder is there. Within that, clustering folder is there. You can go through that clustering folder. This is our main folder. Within this main folder, there is machine learning code folder. I just added, and you need to go through this clustering folder. So you will get data set, and you will get So CSV files and IPython notebook, everything you will get. Okay, so I will upload that project data also, whatever the real-time project we are going to discuss, right? So that file also I will upload here. So now you will get 4 files. We just go through it, and during our Monday session, we will discuss about this K-means algorithm, and we will discuss about this WCSS, and we will discuss about this entire project. So before that, I want everyone to go through the code and try to understand on your own. Why? Because whatever the code I have written, that is already we discussed as part of our Python coding. Clear, everyone? Okay, guys, we'll connect on Monday. The code is there. The recording I will upload now. So just go through it and practice for this weekend and come up with your questions. And you should be in a situation to answer my questions also on Monday. Okay.